Hi everyone! So, it's Christmas today, so Merry Christmas everyone. And for this 5th day of Christmas, we will take it easy. We'll just evaluate this problem, namely the derivative of ax squared plus bx plus c. So let's get started. So first of all, we can use the power rule. So derivative of x squared is 2x, so we have 2ax. Derivative of x is 1, so we have plus b. And derivative of c is 0, so we have an answer of 2ax plus b. So yeah, it's one pretty easy problem. So this is the only thing. So guys for watching my video. Bye. Okay, yeah, that was maybe too easy. So let's try to make it harder. So let's try to solve this thing using absolutely no calculus. So now that will be more interesting and it'll actually give me content. Okay, so let's get started. First of all, let's get a sense for what we could do. So we have our parabola y equals ax squared plus bx plus c, and then we choose a point P on the parabola which will have coordinates P comma ap squared plus bp plus c. So let me indicate its coordinates right here. Actually, I don't need to indicate its coordinates because I don't need it. And now, what will be the tangent line to this? Well, recall that a line is tangent to a curve if and only if it crosses that curve at exactly one point. So it means, for example, let's say this is the tangent to our curve. You can see it crosses the line at only the point P. So basically, our plan is to formulate an equation for the line going through P and with slope, say, m. And what we want to do is we want to solve for m such that there is only one intersection point between the parabola and the line, and that m will be our answer because the derivative is literally defined to be the slope of the tangent line at a curve. Okay, so let's get started. So let's call this line LP. It'll have an equation of y equals mx plus y. And now if we plug in our coordinates for p, we get ap squared plus bp plus c is equal to mp plus something. So what we'll do is we'll add ap squared plus bp plus c and we'll subtract mp, because if we plug in p here, the mp's cancel out and we are left with our y coordinate. Okay, so now basically what we want to do is we want to plug in our equation for the parabola y equals ax squared plus bx plus c, and this will give us an equation in x, and yeah, we'll solve it and see what happens. So we'll have y equals, we'll say it's equal to am squared, mx. I mean the y, sorry. So it'll be ax squared plus bx plus c equals mx plus ap squared plus bp plus c minus mp. And now the c's cancel out, and all we're left with is ax squared plus, subtract this term, we get b minus m times x, plus, and then subtract this whole quantity, we have negative, I'll factor out the p, ap plus b minus m equals 0. And now, as we said earlier, we want this line to cross the parabola at only one point, meaning this quadratic must have exactly one solution. But why does a quadratic have exactly one solution? Well, it's when the discriminant is 0. So let's take a look. I'll change color real quick. So if we have a quadratic of the form rx squared plus sx plus t equals 0, then by the quadratic formula, x equals negative s plus or minus the square root of s squared minus 4rt all over 2r. But then if the square root is 0, then the x will be negative s over 2r, and that will be the only solution. So that means we must have the square root equals to 0. So s squared minus 4t is equal to 0. So s squared equals 4rt. So now we can plug everything in. So we have b minus m squared is equal to 4 times a. Sorry. Actually, we'll have 4a times negative p, so negative 4ap times sorry, ap plus b minus m. And now, if we expand everything, we get b squared minus 2bm plus m squared equals negative 4a squared p squared minus 4ap abp, well, apb, I'll write it like that, plus 4apm. And now, if we move all of these terms to the left hand side, we have m squared, and then minus, I'll factor out the 2, so we have minus 2 times b plus 2ap times m, and then we have plus 4a squared p squared minus 4apb plus b squared equals 0. But then, we can rewrite this part as, okay, so this can be rewritten as the quantity 2ap squared. This is obviously b squared, and we can rewrite this as 2 times 2ap times b. And now, this is exactly a binomial expansion of 2ap minus b, but whole thing squared. So we have 2ap minus b, sorry, 2ap minus b whole thing squared. All of this is equal to 0. And all that is really left now is to solve for m. So we have m equals 2 times b plus 2ap plus or minus the square root of 4 times b plus 2ap squared. And then, wait, actually this was supposed to be a plus for apb, so this was plus 2ap plus b squared, sorry for that, I just realized my mistake. And now we have 4 times this, minus 4 times 1 times 2ap plus b whole thing squared, all divided by 2 times 1, which is 2. But then, here's what's nice. This square root is exactly 0 because we're subtracting one thing from itself. So this is just 0, and all we are left with is 2ap plus b. But then, that was the slope at a point P, and that was the slope of the tangent line. So we can conclude that actually we can write the answer here. Replacing P by X, we have that the derivative of ax squared plus bx plus c is just 2ax plus b. So yeah, this was much more complicated than actually using the power rule and taking the derivative normally, but I must say it was pretty fun, and that's what mathematics is about, making things way more complicated than they should be. This is partially true, honestly, but yeah. So yeah, this is it. Thank you for watching my regular video. Bye. And of course, Merry Christmas.